Next up, we're going to be talking about loops. So what exactly are loops? Next up, we're going to be talking about loops. So what exactly are loops? Next up, we're going to be talking about loops. So what exactly are loops? Next up, we're going to be talking about loops. So what exactly are loops? Next up, we're going to be talking about loops. So what exactly are loops? Well, as you could probably tell by that statement right there, a programming loop is a statement that is used to run certain instructions repeatedly, just like how the opening statement of this topic was repeated 5 times. Loops are very useful for a variety of reasons. For instance, imagine you want to print something 15 times. Sure, you could just copy and paste the print statement 15 times, but this is really annoying to have to do, and becomes even more unrealistic when that number goes up to, say, 100 or so. Now, what if instead of rewriting the same instructions over and over again, you could simply place the print statement inside of a loop, and it will occur as many times as you would like. Now that's the power of loops. With loops, we're able to repeat parts of code multiple times. Now there are 3 different types of loops that we will be discussing today, and up first is the for loop. A for loop is very useful for situations like the one described above, where you would like to carry out a certain set of instructions numerous times. The syntax for a for loop varies depending on the language, however it usually consists of 3 parts: an integer value, a condition which the integer value must meet in order to exit the loop, and an operation to modify the integer value after the instructions inside of the loop are completed. Each time the for loop runs, the operation you set will be performed on the integer, and as long as that integer still meets the condition you set, usually being greater than or less than a constant value, the for loop will continue to run. Eventually, when the integer has been modified by either increasing or decreasing it to the point where it no longer meets the condition, the for loop will terminate and the code will continue to run. For example, let's say our integer value is I and we set it equal to 0. Then we set the conditional statement as I being less than 3. So basically we're saying that as long as I, the variable we just created, is less than 3, continue running the instructions contained within the loop. Finally, we make the operation I++, meaning each time the loop runs, we will increase it by 1, and inside of the loop, let's just put a simple print statement. Now, let's run through the for loop. We start with I equals 0. 0 is less than 3, so we enter the loop and print out hello world. Now that the instructions are done, we add 1 to I, making it 1. Moving on, 1 is again less than 3, so we once again enter the loop and print out hello world. Again, we add 1 to I, making it 2 now. 2 is still less than 3, so we enter the loop again and print out hello world. Finally, we add 1 to it once again, and it becomes 3. 3 is not less than 3 though, it is equal to 3, and so we don't enter the loop and it terminates, moving on to the next segment of code. This is a simple example, but you can extrapolate it across programming to fit your needs. Now, when using a for loop, you have to make sure to set up a condition that, given the initial integer value and the operation, will at some point not be met, to avoid creating an infinite loop and crashing your program. An infinite loop occurs when you give a for loop a condition which will always be met given the parameters of the program, and so the software crashes. For example, a for loop beginning at 10 and checking if I is ever less than 0, and then adding 1 to I at the end of the loop will never terminate since I will just increase infinitely. After the for loop is the very similar for each loop. A for each loop, or a for in a list loop in Python, is used for iterating through arrays or lists. Essentially, the loop will go through each element in the array and carry out some set of instructions for each value. If you would like to read all of the elements in an array and compare them to some value or perform some operation on them, a for each loop is extremely useful. So for example, we could have a for each loop which iterated across an array and simply printed out the value of each array location. Next up, we have the while loop. A while loop will continually carry out its instructions while a conditional statement given to it is true. This can be as long as a certain variable is true, as long as a number is less than another number, or while a value is still equal to another value, for example. While loops are different than for loops in that the loop is not contained within one statement, but stretched out and will continue to run as long as this condition is true. Like a for loop, you could make the condition such that it will eventually return false and exit the loop. However, while loops will not crash your computer should you create an infinite loop. In fact, it is very common for while loops to run infinitely, as, for certain programs, you would like the program to continually be iterated through instead of running once, all the way through until you exit out of the program. When programming a game, for instance, a while loop would be used to iterate through your code, continually refreshing the screen as the game runs. From there, you could perform operations on the screen to make the game playable. Creating an infinite while loop could be done by simply using the syntax while true, as the condition true will always be evaluated as true. Finally, I'd quickly like to cover the extension of a while loop, the do while loop. Do while loops are very similar to while loops, except they will carry out their instructions at least once, even if the condition is false, and then will carry on like a basic while loop. Essentially, the conditions inside of the loop will run at least once, and then if the condition is still met, they will run again and function as a normal while loop would. As you can see, Loops in their many varieties have some extremely useful functions. Using them, you are able to perform an operation many times in a row. You can iterate through arrays and lists, and overall decrease the clutter of your code.